Hello students, welcome to fifth lecture of chemistry in everyday life. So in this lecture we are going to discuss about our last point of this unit, cleansing agents. So these type of compounds are used for cleaning purpose and we already know how they work. We discussed about the cleansing action of the detergent in surface chemistry. They form micelle formation and it is a kind of colloidal solution. So that's why we discussed about it in surface chemistry. So now specifically we are going to discuss about how can we make these type of compounds and how their work is already discussed. So in this section we will learn about the detergents. Two types of detergents are used as a cleansing agent. These are soaps and synthetic detergents. This improves cleansing property of water and this helps in removal of fats which binds other materials to the fabric or skin. And usually fats are oily substances, so we are talking about the grease and the dirt particles attached with those grease like substances. So manufacturing process is as mentioned here. We have glyceryl ester of stearic acid, that means it is a one type of fat. So as we can see, it contains very long chain of carbon. So at the end of these chains, as we can see, we have C17H35, that means a very long hydrocarbon chain. So this type of glycerol ester will react with sodium hydroxide and you will get sodium stearate, which is known as soap or detergent material. So in this kind of molecule we have a long hydrocarbon chain which is non-polar by nature and a reactive group. In this case we have COON, a reactive group which will be polar in nature, and then as a side product we have glycerol, also known as glycerin, and it is the compound can be used in soap as well. Soaps are the detergents used since long. Soaps used for cleansing purpose are sodium or potassium salts of long chain fatty acids, example stearic, oleic or palmitic acids. Soaps containing sodium salts are formed by heating fat, that means glyceryl ester of fatty acid, with aqueous sodium hydroxide solution as the reaction discussed above. This reaction is known as saponification, okay, manufacturing of soap. In this reaction, ester or fatty acids are hydrolyzed and the soap obtained remains in colloidal form. It is precipitated from the solution by adding sodium chloride. So as mentioned, it is related to surface chemistry because soap molecules are able to form colloidal particles named as micelles. So that's why it is mentioned they will form colloidal solution first, and then we have to add some electrolyte which can coagulate these type of colloidal particles. The solution left after removing soap contains glycerol, which can be recovered by fractional distillation. Only sodium and potassium soaps are soluble in water and are used for cleansing purpose. That means other type of salts are insoluble, and if they are insoluble then we cannot use them for washing purpose. Generally potassium salts are soft on skin than the sodium salts, and these can prepared by using potassium hydroxide instead of sodium hydroxide. Now next point, type of soaps. Basically all the soaps are made by boiling fats or oils with suitable soluble hydroxides. Variations are made by using different raw materials. That means we are talking about the colors and smells and some other materials which can either increase the cleansing action or makes soaps softer. So toilet soaps are prepared by using better grade of fats and oils, and care is taken to remove excess alkali. Color and perfumes are added to make this more attractive. Soaps that float in water are made by beating tiny air bubbles before their hardening. That means they will be air containing or porous from the inside. Transparent soaps are made by dissolving the soap in ethanol and then evaporating the excess solvent. That means we are talking about soap like pears. In medicated soap, substance of medicinal values are added. In some soaps, deodorants are added. Shaving soaps contains glycerol to prevent rapid drying. Now glycerol is a thick material containing multiple OH groups. That's why it will create multiple hydrogen bond with water and it will stick to the skin for longer period. Normal soaps are quickly drying soaps and glycerol containing soap or shaving creams stays for the longer period. A gum called rosin is added while making them. It forms sodium rosinate which lather well. Laundry soaps contains fillers like sodium rosinate, sodium silicate, borax and sodium carbonate. Soap chips are made by running a thin sheet of melted soap onto a cool cylinder and scraping off the soap in small broken pieces. Soap granules are dried miniature soap bubbles. Soap powders and scouring soaps contain some soap and scouring agent abrasive such as powdered pumice or finely divided sand and builders like sodium carbonate and trisodium phosphate. Abrasives are material used for creating friction purpose or for removal. For skin purpose, let's say dried skins, and builders make the soap act more rapidly. The cleansing action of soap, as mentioned, we already discussed in surface chemistry unit. Next point, why do soap not work in hard water? Hard water, that means different type of salt containing water. So hard water contains calcium and magnesium ions. These ions forms insoluble calcium and magnesium soap respectively when sodium or potassium soaps are dissolved in hard water. So as mentioned earlier, only sodium and potassium salts are soluble in water and remaining salts of this type of fatty acids are insoluble. So here same type of thing is happening. We are adding sodium or potassium salts, but water contains other ions which will combine with fatty acid molecules, and that's why soap will turn insoluble. So as the reaction suggests, we have C17H35COONA soap molecule with calcium chloride impurity or salt present inside the hard water. It will give us NaCl and C17H35COO twice Ca. That means insoluble calcium stearate soap. So this is insoluble and that's why now soap molecules cannot act as cleansing agents. And they are insoluble, so they will be separated out as insoluble residue. As the description says, this insoluble soap separates as a scum in water and are useless as cleansing agent. In fact, these are the hindrance to good washing because the precipitates others onto the fibers of the clothes as a gloomy mass. That means it will even spoil the clothes. Hair washed with the hard water looks dull because of this sticky precipitate. So we can say that on the surface of hair, this mass of calcium insoluble salt will stick and dried out. So dye does not absorb evenly on the cloth washed with the soap using the hard water because of this gloomy mass. So we can say that it will form a layer on the each and every substance which we use. Now second part of this topic is synthetic detergent. Synthetic detergents are cleansing agents which have all the properties of soap but which actually do not contain any soap. These can be used both in soft and hard water as they give foam even in hard water. Some of the detergents give foam even in ice cold water. So synthetic detergents are mainly classified into three categories: anionic detergent, cationic detergent and non-ionic detergent. So as it is mentioned, it is a stronger compound if we compare it with the soap. But usually we know that we cannot use detergent for skin because they are comparatively harsh. For clothes or other material we can use the detergent, but for skin type we cannot use it because it is comparatively harsh compound. So first, anionic detergents. Anionic detergents are sodium salts of sulfonated long chain alcohols or hydrocarbons. Alkali hydrogen sulfates are formed by treating long chain alcohols with concentrated sulfuric acid are neutralized with the alkali to form anionic detergents. Similarly, Alkyl benzene sulfonates are obtained by the neutralizing alkyl benzene sulfonic acid with alkali. So as we can see in the reaction, we have lauryl alcohol, that means a long chain alcohol. With H2SO4, it will give us lauryl hydrogen sulfate. So we can say that it is a acidic compound, so it will be neutralized with NaOH and it will give us sodium lauryl sulfate anionic detergent. Now why anionic is mentioned? Because when we dissolve this compound in water, it will separate out from the Na plus. So we have CH3 CH2 10 times CH2 OSO3 minus ions present inside the water, and it will act as detergent, and Na plus will be separate out from it. So that means we have a negative ion which will act as detergent ion. Then we have second type, dodecyl benzene, which contains total 12 carbons as a chain attached with benzene ring. And same type of reaction will be obtained. When it reacts with H2SO4, it will give us dodecyl benzene sulfonic acid. SO3H group will be attached with benzene ring. When it is neutralized by NaOH, again same type of ion will be obtained and you will get sodium dodecyl benzene sulfonate. And again same type of reaction will be obtained. In this case, you will get CH3CH2 11 times C6H4SO3 minus ion, and Na plus will be separated out in solution because of ionization. In anionic detergents, as we discussed, the anionic part of the molecule is involved in the cleansing action. Sodium salts of alkyl benzene sulfonates are an important class of anionic detergent. They are mostly used for household work. Anionic detergents are also used in toothpastes. Next point, cationic detergents. So as we know, if anionic detergents contains anion as the cleansing agent, then in this case it will be positive ion or cation. So cationic detergents are quaternary ammonium salts of amines with acetates, chlorides or bromides as anions. Cationic part possesses a long hydrocarbon chain and a positive charge on the nitrogen atom. So keep in mind, all of these cleansing agents will contain a long chain hydrocarbon which will act as a non-polar part and a polar head which will be negative or positive in nature. So that's why it can stick with both type of compound. Non-polar portion will attach with oil or grease like dirt like particles, and polar part will combine with water molecules, so that it will act as a link between polar and non-polar molecule. So because of positive charge on the nitrogen, these are called cationic detergents. Cetyl trimethyl ammonium bromide is a popular cationic detergent and is used in hair conditioner. So here structure of compound is mentioned, and as we can see, we have a positive ion which contains a quaternary nitrogen, that means nitrogen attached with 4 different organic groups, and it is positive in nature, and Br minus is present for neutralization. Cationic detergents have germicidal properties and are explosive, therefore these are of a limited use. Germicidal, that means it has germ killing properties. And last portion of this topic, non-ionic detergents. So non-ionic detergents do not contain any ion in their constitution. One such detergent is formed when stearic acid react with polyethylene glycol. So reaction is mentioned, we have CH3CH2 16 times COOH stearic acid with polyethylene glycol, and with the removal of water molecule, both the molecules will combine with each other to form this type of detergent. Liquid dishwashing detergents are non-ionic type. Mechanism of the cleansing action of this type of detergent is the same as of the soaps. This also removes grease and oils by micelle formation. And we know that micelles trap the grease or dirt like particles inside them, and they will prevent them sticking back to the surface. Now main problem that appears in the use of detergent is that if their hydrocarbon chain is highly branched, then bacteria cannot degrade this easily. That means we are talking about environmental effect. Slow degradation of detergent leads to their accumulation. That means it will be collected over the time and quantity of these type of undegraded detergent will increase. Effluents containing such detergents reach in the river, ponds, etc. Now effluent, that means liquid discharged or waste material which is diffused inside the river or sea. These persist in the water even after sewage treatment and the cause forming in river, ponds and streams, and their water gets polluted. These days, the branching of the hydrocarbon chain is controlled and kept to the minimum. Unbranched chain can be biodegraded more easily and hence pollution is prevented. But right now, these type of unbranched chains are comparatively less efficient than the branched components. So that's why we still using these type of branched component, but we are trying to find new ways which can prevent the pollution, and we are trying to find biodegradable detergents which are comparatively efficient as well. So here our unit is complete. If you find any difficulty in these topics, then feel free to ask. Go check the questions mentioned in exercise. If you find any difficult question in this exercise, then feel free to ask. We will discuss them in detail in upcoming lectures. Thank you.